In the course of dynamics, we learned that a force can cause an object to start moving, to accelerate, and to change its direction. Today we are going to learn another thing that a force can do. That is, it can make an object turn around. We say that a force can have a turning effect. The turning effect is what we call the moment of a force. The moment of a force is a quantity that tells us the extent of the turning of a force. It depends on the magnitude of the force and the perpendicular distance of the force from the pivot. Now, what exactly is the implication of this formula, and what is the benefit of learning the moment of a force? To answer this question, let's look at the next example. In this diagram, we have a huge rock. If we try to move it with our bare hands, it will be too heavy for us to move it. However, if we use a metal rod to act as a lever and use a log to act as a pivot, we will find that we can lift the rock. Why is it so? When we apply a downward force, there is a turning effect. The moment of this applied force is equals to the force applied multiplied by the perpendicular distance d1. The turning effect of the force will cause the other end of the lever to exert an upward force on the rock, or we call the load. The upward force F load will also has a moment that is equals to F load times perpendicular distance d2. These two moments have to be equal because it is the same lever, and hence the turning effect has to be the same. However, because the distance d2 is much smaller than the distance d1, when we rearrange the equation, we will discover that the upward force F load is proportionally larger than the applied force F. In other words, if d1 is 10 times the length of d2, then the force on the load will be 10 times the applied force. Hence, we say that the turning effect or the moment of the force magnify the force. The degree to which the force is magnified is called the mechanical advantage of the lever. With this knowledge, you can design levers that can magnify small applied force simply by varying the distances d1 and d2 accordingly. This is the reason why knowledge on the moment of a force is very important. In fact, many tools that we use every day make use of the moment of a force. We will learn more about this in subsequent lessons. If you find this video useful, do remember to subscribe to my channel so that you can be notified when we post the next lesson.